So in the next two videos, we're going to work through a couple of representative calculations relating to carbon dating and kinetics and half-lives. So in this question here, we're given some information about carbon-14 dating, and we're given the initial activity of any carbon-14 sample when it is sort of new and alive. So a starting activity. This is going to be our A1 value, and it is in 0.255 becquerels per gram, which is a little bit different units than what we had before. But like I said when we were deriving our equations, it doesn't actually matter what our units are, as long as our initial activity and our final activity have the same units, because then they'll cancel out. So first of all, we're told that carbon-14 undergoes beta decay, and we're asked to write a balanced equation for this reaction. So we start off with carbon-14, and we know that it's going to give us a daughter isotope, some sort of decay product, and one beta particle. To be able to balance this equation, I also need to know the atomic number of carbon, which I happen to know is 6, but if you don't, then you should look it up on a periodic table. Then to balance the equation, our mass numbers have to balance, our atomic numbers have to balance, so 14 is equal to 14 plus 0, 6 is equal to 7 plus -1, and element number 7 is nitrogen. And again, if you didn't know that, look it up on the periodic table. So we are seeing that the natural product of the decay of the carbon-14 isotope is nitrogen-14, which is a nice, stable, super common isotope of nitrogen. In the next part of this question, we are told that we are studying a wooden tool that may or may not be really old, and it has been measured to have an activity of 0.195 becquerels per gram of total carbon. So this is our current activity. This is our A2, 0.195 becquerels per gram. And we'll recall from the previous page that our initial activity was 0.255 becquerels per gram of carbon. And the good news is those are in the same units, so we are set. We are good to go. But we're missing one more piece of information. We need to know how fast carbon-14 decays, which means we either need to know the decay constant or the half-life, neither of which were provided in the question. However, if you go back one more page in your notes, you will find that you were told that the half-life of carbon-14 was 5,730 years. And so that will be our missing piece of information. Anytime that you're not directly provided with information in a question, start by looking at the context. Maybe it was in the previous question. Next, check your data sheet. And if you're writing a practice test, that means the data sheet that came with that practice test, not the generic one. It's probably there. So once we've looked up all the pieces of information that we need, now we can go ahead and answer our question. And again, there's two approaches we can take. Those of you who took physics and know the physics equation, go nuts, fill in your values, solve for half-life. I'm going to stick with the equations that we are officially using in this course. And so what I need to do is I need to be able to fill in natural logarithms of A2 over A1 is equal to negative k delta t. I'm solving for delta t, so it's okay that I don't know that. I have A2 and I have A1, but I don't have k. I don't have my decay constant. So I'm going to have to solve for it. But that's okay, because I happen to have the half-life, and I know I can very easily get the decay constant from the half-life. So over here, I need to solve for k first. So I know that the natural logarithm of 2 is equal to the decay constant times the half-life, and therefore the decay constant is equal to the natural logarithm of 2 divided by the half-life, and the natural logarithm of 2 divided by 5,730 years is going to give me a decay constant of 1.21 times 10 to the minus 4 inverse years. Now I have K, now I have A2 and A1, now I can solve for delta T. So I rearrange my equation by dividing both sides by negative K, and that will get me delta T equals the natural logarithm of A2 over A1 divided by negative K, and then I can fill in my numbers. So A2 was 0.195 becquerels per gram carbon divided by A1, which was 0.255 becquerels per gram carbon. And the becquerel per gram carbon all cancel. Hooray, no units left in my log. Divided by negative 1.21 times 10 to the minus 4 inverse years. And remember, dividing by inverse years is going to give me an overall unit in years. Plug everything into the calculator, and I should pop out an answer of 2.22 times 10 to the 3 years, or approximately 2,220 years. So my wooden tool is about 2,000 years old, 2,200, give or take. If I thought it was 20,000 years old, it probably isn't. If I thought it was 2 years old, I'm probably also wrong. But if I was expecting a value in the ballpark of 2,200 years, then I've confirmed my supposition that this tool actually is the tool that I thought it was, of the age that I thought it was.